this project is about education, why people get education, why there is a return to education. And in some ways, it's about very old questions. It's essentially about the human capital versus signaling debate. But I hope to contribute some new thoughts and also some new evidence to this debate. So the starting point is a little bit more introspection about how signaling actually works in the real world. So I think we all agree that there is some necessity to overcome imperfect information, to overcome asymmetric information. You need to somehow signal to the labor market what kind of person you are, what skills you have. But of course, in the real world, it's much more complicated than in simple models. So often signals are very much imperfect. So for instance, something like having graduated from college is a coarse signal. There is a lot of variation in skills, even within these categories of college and non-college. And then there might be sort of other types of signals that can be more detailed, for instance, something like a grade point average. But it's of course also noisy. It's not clear how closely it corresponds to what employers need to know. And then there is sort of more, technical targeted aptitude tests, something like the graduate record exam and so on. These might be more precise, but they're also quite narrow. But anyway, the point is that unlike in Mike Spence's original model, employers just never observe all the actions, or in his model, it's all about you take an action and that reveals who you are, but employers don't observe all the relevant actions, nor the relevant traits of individuals. And there is actually more, besides this kind of introspective argument, there is systematic evidence that signal imperfection should matter, and that is the literature on employer learning. So what do I mean by employer learning in this context? Is the idea that initially employers are uncertain about workers' abilities, but over time abilities get revealed. And there is a lot of evidence for this process in various contexts. So what that shows is that clearly asymmetric information matters. There is initial uncertainty. It also shows that education does not reveal everything. So if you had a sort of a separating equilibrium, as in the Spence model, then there could be no learning because everything is revealed. People take an action that reveals everything, and then actually there is, in equilibrium, there is no asymmetric information anymore. But this evidence of employer learning shows that there is something that is not revealed initially. And there's also another important consideration when it comes to employer learning, which is that the faster is this employer learning, the less important is the signaling motive. Because as a student, you might just say, oh, it's fine, I will get a bad wage initially, but employers will figure out who I am very quickly, so I don't need to bother with going to college for 5 years or something like that. Yeah, so that's also an important consideration. What I want to do based on this motivation is to develop a theory that combines all these elements. So a model that has both signaling motives, so it has some asymmetric information, but also a scope for human capital accumulation and employer learning. And there's one assumption that I maintain throughout that's just important, that we're sort of on the same page here. So I do assume that schooling has some productive effect. And this is typically not controversial. Like, even people who think signaling is very important, they would say, yeah, there's a productive effect, but it's very small. Or schools are bad, so they don't really teach people in the way that they could be taught. But just theoretically, that's sort of an important premise for what I want to do here. And then also the type of employer learning that I consider is what is so-called symmetric employer learning. So there's, it means that basically your ability is the same wherever you work. There's no match specificity, there's no search frictions and so on, and therefore no rents. This is just for simplicity. It would be interesting to eventually study those aspects as well. So I have this richer model, which I will show nests sort of earlier models. And so that lets me then establish theoretically first how privately optimal choices may deviate from what's socially optimal. So what's socially optimal is the same as what you would get in a decentralized equilibrium when there is no information frictions, basically, and no other frictions. And I provide some evidence on the nature of inefficiency. So I structurally estimate my model on NLSY data, which is the data set that the employer learning literature has used a lot. And I also show some reduced form evidence from Swedish high school graduates. And so what I find, and what is the new angle that I introduce, I think, in this paper, is that imperfect information actually can lead to underinvestment. So in the typical signaling view, education is wasteful because it doesn't really add much to your productivity. But once you overcome that sort of extreme view, then it becomes a question of, okay, the productive investments that you do make in school, how are they going to be rewarded by the labor market? And if you cannot communicate, if you cannot reveal what you've learned fast enough, then it may be that you underinvest because the return is too low. And this is a possibility that I established theoretically, and it actually seems to be the case in the data. So what the results suggest is that students put in too little effort into studying, both in high school and in college. The fraction attending college relative to this perfect information counterfactual might be too high, but this is sort of difficult to say with any confidence. This depends a lot on assumptions. And then, you know, again, you can use, obviously, once you've estimated the model, you can make lots of statements, but again, they're very sensitive to assumptions. For what it's worth, so far, what I've been able to quantify, so the output loss from information frictions doesn't seem to be that high. It seems to be around 5 to 10% in the US. And one reason for that is that employer learning is actually quite high in reality. So that's what I'm trying to do in this paper. And obviously, there is lots of aspects of education and the labor market that are not in here. But given that, so for instance, I don't talk about firms' market power, I don't talk about behavioral aspects of education. There's a large literature, of course, showing that students might not be fully aware of what opportunities they have once they go to college, for instance. Students might be myopic, especially early on, for instance, biological reasons, and so on. All of this is sort of not part of the analysis here. And that's just because I want to, you know, basically do this step by step, introduce a richer framework than what we've had before, but obviously it cannot get too complicated. Otherwise, there's not much I can say. Okay, yeah, so why do we care about this? Well, most of us here, or maybe all of us, work in the education industry, so we should care about this personally. We should have some views on whether what we do is useful. But as a society, of course, we should care. We spend vast resources on education, lots of time on education. So we should get an idea of whether this is efficient, and if not, what policy might do differently. Also, for important background, for those of you who don't work on this or haven't sort of checked in on this debate recently, so what's the current state? Human capital versus signaling debate. So there's sort of two sides to it. One side really emphasizes the implications of employer learning. So employers figure out who you are very fast. and therefore signaling plays a modest role. And this is maybe a majority view, I think it's fair to say, among education economists. But there is also opposing views. So Brian Kaplan famously wrote a book in 2019 called The Case Against Education. And he thinks that signaling makes up the majority of education weight premia, and therefore is the most important reason why people actually go to school. And according to maybe a sort of outside observer of this literature, Phil Oriopoulos, in a book review, reviewing a different book, not the Kaplan book, but anyway, he says that to him the debate has not been settled yet. So in some ways, why it hasn't been settled perhaps is because everyone agrees on a few things that are kind of very basic and they're not controversial. So everyone agrees, it seems, that information frictions are important in the labor market and that education increases productivity, at least to some extent. Maybe not by much, but anyway. So the big question is, what is the relative importance of these two forces? And that's what people disagree on. But what I want to contribute with this paper is to say that, or actually the evidence on employer learning has implications that have not been, I think, fully appreciated. So what I get out of this is actually a further complication, which is that due to information friction, students may underinvest in their human capital. Okay, yeah, and I will skip the literature review in the interest of time. And yeah, so I was told we have time afterwards for questions, but please interrupt me if there's anything you think should be clarified. I'm actually happy to take any questions, and then we can decide whether to deal with it right now or postpone it to the end. And of course, you can also use the chat. I'm happy to use that as well. So let me, yeah. So what's the structure of this talk? Let me try and go through the theory quickly and sort of high level, because it easily gets complicated and one gets lost in detail, which is not necessary, which I would like to avoid. But there are a few theoretical insights that I want to convey and also maybe give intuition for them. And then, of course, it's important also to have an idea of what this model is that I'm trying to then estimate. Towards the end, I will also have some reduced form evidence from Sweden. Okay, so the basic idea is that there's two things that determine how productive you are. So one is the schooling that you acquire, which I call SI. I is individual, and the other is your pre-existing talent, theta. And here I denote log output by little y, and yeah, AS and A theta are the importance of schooling and talent in the production function. So why is there subscript IT? So T is the amount of experience that you have in the labor market. Your productivity is actually not time varying, but your wage might be time varying, and that's because of what the market knows about you. So I assume that, so I will get to how schooling is chosen later, but basically you decide your schooling first, and then you enter the labor market, and at that point the market observes a signal about your schooling. So the market doesn't necessarily observe precisely how much you've learned, but the market observes some signals. So there's this noise term, UI. And then once you work, the market also observes output signals. This is the standard employer learning framework. So every period you produce something, and then your employer, imagine you're in a large firm, you're working in teams. The employer cannot precisely see what was your contribution. There's some idea, but there's also some noise. So that's the epsilon IT, that's the noise. And here's where the time varying aspect comes in, that basically there is like a new noise every period, and then there is a public history of output observations. That's the symmetric employer learning part. The market observes what you do. Is obviously stylized, but it's a useful assumption here. And then the idea is that over time the market has a better and better idea of how productive you are. And the variances of the noise parameters are really the key parameters of this model, because they determine the extent of information frictions. And all of the existing literature assumes that that the schooling choice is observed perfectly. But this is what I want to relax here. That's the first sort of key novelty of this paper. So the variance of the schooling noise is can be positive and potentially very large. Okay, so what does this information structure mean in terms of wages? So assume that firms pay you your expected marginal product. Then we get, from the point of view of the worker, a log linear wage equation. So it's linear in schooling and in talent. And the key question is how the return to schooling, the private return, wage return, the beta S, how it compares to the social return, which is the effect of your schooling on productivity, which is AS. And in fact, the private return is a weighted average of some initial information term and the social return. And the weights come from the employer learning structure. And they have the property that this lambda t has the property that it goes to 1 as time goes by. So after many years in the labor market, your productivity is fully revealed, and therefore the private return at that time in the future that you will enjoy from your schooling is equal to the social return. But initially, the lambda t might be very far from 1. It could be 0 essentially, and then this initial information is all that influences your private return. So there is going to, in general, there is a wedge between the private return and the social return. The wedge disappears over time, so because of this 1 minus lambda term here, which goes to 0, and the sign of the wedge is ambiguous. That's the key insight from this novel sort of framework that I propose here, which is just a tiny modification actually, but it has important implications. So the sign is, of course, if the schooling was perfectly observed, meaning that sigma u square is 0, then the wedge is going to be positive. Private return above social return, people overinvest. But once sigma u square is positive, the sign of the wedge could be the reverse as well. And if you could measure the private return over time, or as it evolves with experience, you could actually tell what is the sign of the wedge, because the pattern of convergence towards the social return is monotone. So either you converge from above or from below, and if you converge from above, that means the private return initially is inefficiently high, and if you come from below, it means it's inefficiently low. So that's a potential empirical test. But this simple framework, it's a bit difficult to take to the data, so I need to add more structure later on. But anyway, just in terms of closing the model, because I've talked about signaling a lot, of course, without actually having shown you the choice of the workers. So it's in some ways very standard. So there is some cost of acquiring the schooling. Yeah, so first you spend some time in school before you enter the labor market. And this cost depends on ability, theta. I also have a taste parameter gamma, which has, we can talk about that if you want at some point, but it's not critical now. But the key is that if you're more talented, it's easier to get schooling. That's, you know, as in the Spence model, a key assumption. And that means that schooling potentially is a signal. It can function as a signal of talent because of this, what's technically called a single crossing condition. So what's different here to the standard model is that once you enter the labor market, your wage is time varying because of the employer learning. So both the return to your schooling and the return to your to talent will be time varying. Yeah, and of course the functional forms are chosen in a way such that everything stays tractable. So optimal schooling is actually going to be linear in talent and taste. And if you assume that talent and taste are jointly normally distributed, then also schooling will be normally distributed, and then everything works out in terms of the employer learning framework. Okay, so yeah, I'm not going to talk too much about this, but this simple model already has some useful insights. I think we talked about underinvestment, overinvestment, but it's also, I think, nice in that it combines the employer learning aspect, which isn't in the original Spence model. And the original Spence model is nested here. And also, if you worry about things like pooling equilibria and so on, things are actually a lot easier once you have some learning. Once there is additional information later on, you can rule out lots of these sort of strange equilibria that you often get in imperfect information games. Okay, but as I said, this simple structure is not good enough yet in terms of a mapping to the data, because we need to think about the length of schooling versus knowledge obtained. That's in terms of the data, I think is a very important distinction. So for instance, you might ask, what is this SI here that people choose? Is it years of schooling? No, it's not, because I assume that years of schooling is fixed. So it's really how much you learn for a given length of education, but clearly people also make a choice of the length of education. So that's why I want to enrich the model by basically allowing for 2 tracks, high school or college. So it's a little bit like sort of an extreme tracking system. For instance, in Germany, I don't know how it works in Poland, but in Germany, students have to choose, or their parents have to decide quite early on whether you're going to go on the academic track, which allows you to go to college, or whether you go on a sort of more vocational track. But anyway, I could assume that everyone first completes high school and then they decide whether to go to college as well. That will just make the exposition more tedious. So these things become important if you think that there is new information about people's ability as you learn, as you are in high school. Obviously, that is the case in reality, but it's not something I want to focus on here. So then it's just easier to have these 2 tracks. There's a college track and there's a high school track, and you decide at the beginning of your life. And so within each track, you choose how much schooling to obtain. And so college graduation is an additional coarse signal as well. So as before, how much you've learned, that's observed with noise. Maybe it's a grade point average or something like that you show the employer, but it's not perfectly observed. But whether you went to college or not, that's perfectly observed. And then the 2 tracks also represent different learning technologies. So this cost function is different across the 2 tracks. And it's different in a way that favors high-skilled people. excuse me. So, of course, empirically, we observe high ability people on average are more likely to go to college. So that's captured in these learning technologies. Okay, and so then equilibrium beliefs will differ by track, and then there's some details on how exactly the expectations work, but I think I can skip that. So now we have this infinite horizon problem that basically we can proceed by backward induction. We can say, what would I do if I chose college? What would I do if I chose high school? What would I do, meaning how much would I learn? And then what is the lifetime utility I get out of each of these choices, and then just compare. So I go to college if my, by the way, also another nice thing, so the lifetime utility, the value function, is actually linear in theta, so in type and taste. So then I go to college if my utility from going to college is no less than that from going to high school. Very simple. And you get sort of a simple selection rule. Like what kind of person goes to college? Well, either you have high talent or you have high taste for learning, or both. Okay. So let me build a little bit of intuition here. So in this model, why do people want to attend college? Well, you acquire more human capital, which could be valuable in the labor market, but then the question is, to what extent does it get rewarded? How quickly does it get observed, basically, by the market? You acquire an additional coarse signal, so you have an easier starting position in the labor market. Even before the market knows anything about your ability, they will infer something about you if you show your college diploma. And yeah, so the learning technology favors high ability students or high taste students. On the other hand, of course, there's a trade-off here, right? There's clear advantages from just choosing the high school track because it's shorter, so you enter the labor market sooner. And in relative terms, the learning technology favors low ability or low taste individuals. I also allow the learning parameters to differ by track. So this is something that the literature has established, that employer learning has a different speed in different parts of the labor market, presumably because the production process is different. So for instance, the amount of human capital that, so it might be because of the production process, but it might also be about, for instance, the diploma or the transcript. A grade point average from college might be more informative than one from high school. So in any case, the fraction attending college in an imperfect information world is likely to be different from first best, but we don't know in which direction it goes. Okay, so that's my framework. There is, I think, some interesting theoretical possibilities, but of course the big question is, so what does reality look like? So we want to have some estimates, and the first thing I'm going to do is to just try and estimate the complete model using data from the National Longitudinal Survey of Youth in the US, which has been used heavily in the employer learning literature. And so the advantage with that is that basically my estimation results will be fully consistent with the existing evidence, but then I will offer an interpretation that goes beyond the prior literature. The disadvantage is that these data are quite dated. So this is a little bit of economic history. This is people who were in the labor market in the 80s and 90s. So it doesn't maybe tell you much about the last 25 years. But anyhow, I think it's important to make the connection with the literature. This is a nationally representative panel survey in the US. And what's nice about it is that in addition to wages and education, you also observe this, what is called the AFQT score. So from the Armed Forces Qualifying Test, I think is what it stands for. It's very similar to an IQ test, but it's administered to everyone who participates in this survey. So it's not a super large sample. I end up with 3,600 individuals, and yeah, it's a panel. So almost 33,000 observations in total. And in this sample of workers, it's just one fourth, actually probably 26%. But anyway, yeah, about 1/4 who completed college. And I think it's also useful to talk about what I would ideally want to estimate. So I would like to run this regression up here, which has, so at each level of experience, I would run this regression where there's a college dummy, and then the amount of human capital that people obtained, and the pre-existing talent. But I don't observe the latter two variables perfectly, at least. I might observe proxies. So I observe this AFQT score or something similar. So let's denote that by Z. And then I can run the following regression, which is what the literature has done. So log wages on an indicator for college, or actually years of schooling in the existing literature, but you get very similar results, and the AFQT. And this regression does not need to have a causal interpretation. What I care about is what this regression tells me about the regression up here. I care about the relationship between these two regressions rather than a causal interpretation. But if I want to learn about this relationship, I need to assume something about the mapping between human capital and talent to the AFQT. So I assume this linear additive mapping. And I'm going to try to recover these parameters, these loadings, if you want. Yeah, so it's a bit like a factor model. Yeah, let me show you this is sort of a typical pattern that you get from these employer learning models. So this is basically each pair of diamonds and circles is one regression. This is the coefficient on the college dummy, and this is the coefficient on the AFQT. And as you can see, the return to the AFQT increases with experience, and the return to college decreases. And in terms of the employer learning framework, what this reveals is that employers initially do not observe the AFQT. They might observe some proxy, but they don't observe it directly. And in fact, it seems they observe it quite poorly. But as they find out about people, as they observe them in the labor market, they learn. And therefore, wages reflect more and more this AFQT score. On the other hand, college graduation is initially observed perfectly, always observed perfectly, and it is used to infer something about people's productivity. But as employers learn more and more, the effect of college becomes less. Why doesn't it go to zero? Well, because in this regression, we don't capture productivity perfectly. So if I were able to run this regression, perfectly observing human capital and talent, then indeed the coefficient on the college dummy would go to zero. But in the regression that is actually feasible, this won't happen because the AFQT is an imperfect proxy of schooling and talent. but in fact, I can already use this to learn a lot about the model. So what turns out to be useful is actually to run just the regression of log wages on the AFQT score separately for college and high school graduates. And then you can fit a nonlinearly square model to learn something about the employer learning parameters. And here is already a striking result, and this has been shown before in the literature paper by Peter Assediakono et al., that for high school graduates, the AFQT does not seem to be observed at all. Now, given that I allow in my framework, I allow the AFQT to proxy for acquired human capital and talent. And the acquired human capital in the model is a function of talent, among other things. So the fact that there is a zero return to the AFQT for high school graduates actually allows me to infer already that there's nothing in the US, in this particular labor market, that employers learn about, or see, I should say, see about what people have learned in school if they enter the labor market right after high school. So the noise from the schooling signal for the high school graduates is actually infinity. That's very, very striking conclusion, but it comes straight out of this estimation. This curve here, of course, is constrained. So it's it's nonlinear squares, and basically constraining this initial coefficient to zero, so it cannot be negative. And then, yeah, the only possibility is that the schooling signal is infinitely noisy. But then there is learning. So the market does observe eventually, but it takes some time. Okay, but this is just one bit of of all the model parameters. So I want to know all the other parameters as well. And that's difficult. So I need some more structure. Why is it difficult? Well, I'm trying to get at the relative importance of pre-existing ability and acquired knowledge in the production function. That is a terribly difficult task, and there's just no easy way to do this. I also need to know in my model what's the correlation of ability and tastes. And also I have an extension to the model which I need to consider for reasons that have to do with other literatures, as I will discuss in a little bit. I also need to consider that high school graduates and college graduates might be imperfect substitutes. But then you need to measure basically the price of a unit of skill in that type of model. And again, that's a super difficult thing to do. So how can I make any progress? Well, basically I have to fix some parameters or some objects, and I have to say, okay, under these assumptions, this is what the estimation gives me. And the structure of the model is such that actually if I fix the average treatment effect of college on productivity, the type correlation and the production function parameters, I can estimate everything else. And I think it's good to start like this, because these are very difficult objects to estimate. So if you think about all these wonderful papers that estimate some sort of causal effect of schooling on earnings and health and all these other things, they're all local estimates. They're regression discontinuity or IV and so on. You're familiar, right? So of course, I'm going to have in my model, I'm going to have a distribution of treatment effects. But I don't know if I take a given study, say a paper that recently came out in the AR on Norway, estimating effects of compulsory schooling and combined with an employer learning model, actually. I don't know which part of the distribution those treatment effects come from. And conversely, those studies don't give us the average treatment effect of college. But that's in some ways, you know, it's something that policymakers would like to know, but it's really hard to estimate. So I'm going to say, okay, there's huge uncertainty about this parameter. Let's make an assumption, and then let's vary that assumption, and let's see how it impacts the results. That's the approach that I'm taking here. And these are some results that I'm getting. So basically what I'm doing here is 3 different experiments. The first experiment is 0 average treatment effect of college on productivity. Substitution elasticity between high school and college is infinity, so they're perfect substitutes. And the type correlation is 0.8. That's the first experiment. I have more experiments, you know, varying the type correlation and so on, but this is sort of representative actually of the results that I'm getting. And then another experiment says, okay, let's have a higher average treatment effect of college. So this corresponds to like a year of college increases your productivity by 4%. Just, you know, there's a paper by Heckman and co-authors that gives numbers a little bit higher, but I think they capture also the signaling bit. So that's why I go a bit lower here. And finally, I have an experiment where I allow for imperfect substitutes, because when people do this in the data, they ask, okay, are high school and college workers perfect or imperfect substitutes? Typically, they say, no, they're not perfect substitutes. And the substitution elasticity is something like 1.5. Okay, so I allow for that as well. But actually, the patterns then that you get out of all these different experiments are quite consistent. So there is always a productive effect of acquired knowledge. The productive effect of pre-existing talent is a bit more uncertain. In one case, it seems to be 0. These are the loadings on the loadings for the AFQT score, and it seems that the AFQT just only reflects talent. It does not reflect acquired schooling at all. These are this is the noise of the schooling signal. So it's, as we know already, it's infinity for high school. It's still quite large in some cases for college. And then the noise of the output signal, and these are relatively small. So yeah. What does this mean in terms of there's earlier literature that establishes that employer learning seems to be faster among high school than among college? That's because the schooling signal for high school graduates is more imprecise. It's very imprecise. So then you can learn a lot if you start out being completely ignorant, and then you learn fast. Okay, so I should wrap up, but let me show you 2 more things basically. So by the way, then also I checked the efficiency condition that theoretically is ambiguous, but with these numbers, in each case, the within track investments are inefficiently low. So students do not study as hard as they would if there was perfect information. So I've started using this for some counterfactual analysis. So here I do these 3 experiments again, and I compare to what you would get with full information. So the estimation targets the fraction of college graduates at 26%. And this is the output produced by high school graduates, the output produced by college graduates, and aggregate output. And you see that, well, the aggregate output, if you compare with the full information, is lower than on the full information, but not by much. So the losses are about 5 to 10%. The fraction of college on the full information in 2 of the experiments is basically 0. But this clearly is very sensitive to assumptions. So if you assume that there's imperfect substitutability between college and high school, then the fraction of college under full information is basically the same as that which we observe. So this is something that is very difficult to learn about. Okay, so this is, you know, obviously relies on a lot of strong assumptions. So let me just briefly mention that I also did an exercise on the Swedish data where I tried to observe what is the additional human capital that people obtain at a given point in education, in their education. And what I do is basically I say, okay, let's look at the high school GPA, which is the GPA after 12 years. And let's look at the compulsory school GPA, which is after 9 years. And let's say that if we regress the log wage on, and this is a sample of high school graduates only, so they enter the labor market right after high school. If we regress the log wage on the high school GPA, conditioning on the compulsory school GPA, then basically we pick up a return to something like value added, something that was learned in high school, in addition to what the students already knew in compulsory school. That's the idea. Obviously, there's many things that can go wrong here as well, but that's closer in some ways to the spirit of the model, which says you should try and observe additional human capital obtained. And when I do this at different levels of experience, I find again that when people enter the labor market, there seems to be no reward to what they've learned. It takes some time for employers to sort of learn about that. And again, that would suggest that people underinvest if their effort in school really depends on the return. The learning is fast, but still there would be some slight underinvestment. Okay, so let me conclude. Yeah, I was motivated by evidence of employer learning to basically incorporate imperfect signals into human capital and signaling models, and the results to me do suggest that imperfect signals matter, and this means that there are lower incentives to study, and you can use the college signal to compensate. So that might mean that the fraction of people who went to college is too high relative to full information. But at the same time, everything that I did here in terms of the empirical analysis also suggests that schooling has a substantial productive effect. So what this is nice also, I think, is that it can make sense of a lot of other evidence that we have and that sometimes puzzles us. So for instance, if you survey students how much time they spend studying in college, you often find, not always, but you often find that they don't spend too much time studying. They don't work very hard. Of course, there's other things, they socialize and so on, but and that might, there's a networking aspect, obviously, of university. But in terms of just study time in many, especially in North America, I'm not so familiar actually with the European evidence, but in North America, students just don't study a lot, the typical students. And so that suggests, you know, why it suggests a rationale basically for all these things that we do, like exams and perhaps other study incentives, which don't make sense in the human capital world because people will just study whatever they need to succeed in the labor market. Okay, and then, you know, among other things, I think what this paper should or might do is kind of, you know, there's this traditional question, how much of the return to schooling is signaling? This kind of idea of decomposing the returns to schooling, which is of course an important question, but you could then ask, you know, in light of the results from this paper, how much time could students actually save if information frictions were removed? Again, to the extent that college has other functions, that doesn't apply. But if it's just about acquiring human capital think these results suggest that this could be done faster, and you don't need to be in college for 4 years, with all the appropriate caveats that I have mentioned.